Okay, let's take a look at this problem. And the first thing it asks us to do is to find all the possible rational zeros. So we need to take a look at our P over Q, where P is all possible factors of the constant term. There's going to be quite a few factors of the number 68. So plus minus 1, plus minus 2, plus minus 4, plus minus, let's see, well, I can start at the other end and get plus minus 68 because it's 68 times 1, plus minus 34 because it's 34 times 2, and plus minus 17 because it's 17 times 4. I think that's all of those. Our denominator is factors of 5, so we've got plus minus 1 and plus minus 5. So we look at the choices we have, and what we want are all of the possibilities we could have by choosing all of the numerator choices over the first denominator and then all of the numerator choices over the second. It ends up being D because we have the 1, 2, here's the 4 is kind of out of order, and then 17, 34, 68. Then you've got the plus minus 1 over 5, 2 over 5, 17, 34. I don't know why the 4 is out of order, but it's there in 68. It says use synthetic division to test several possible rational roots in order to identify one actual root. Well, having done this a bit and only having a 5-minute video, we're going to use 2. Okay, so I'm going to use 2 as my root. Bring down the 5, multiply by 2, write it here. Add down the column, get a negative 7. Multiply by 2, I get negative 14. Add down the column, I get negative 34. And I wrote a number wrong right here. This is not 62, 68. Okay, now we 2 times the negative 34 to get negative 68. And we have no remainder. This 5, negative 7, negative 34 stand for 5x squared minus 7x minus 34. Okay, and we can factor that. We get 5x and x. And 34 is going to factor into 2 times 17. I need the 17 to be negative, so I'm going to put negative 17 right here so that when it multiplies by that x, I get negative 17x. Then I'm going to put a plus 2 here. Okay, because negative 17 times positive 2 gets me back to the negative 34. 5x times 2 is 10x, plus the negative 17x will get me back to the negative 7x. So this is how that factors. This leads to the solution 17/5. This leads to the solution negative 2. And we have the 2 that we used up here in the synthetic division. So my solution set, which I would fill in there if it would expand, but won't, is 17/5, negative 2, and 2. Okay, and that's how you would work that problem. You could put another root that you could have chosen to do, and the synthetic division would have worked just fine as negative 2, but we chose 2, so I'm going to write that as my one root, and that's how you would work that problem.